In this circuit we have combined an OR gate, an AND gate and a NOT gate together. We have two inputs which we will call A and B. We also have an output which we will label F. Remembering the truth tables from previous videos will help us to analyse the circuit and produce a truth table showing all combinations. So let's start by setting both inputs at 0. The A input sends a 0 signal to the OR gate. The B input also sends a 0 signal. With both inputs being 0 to the OR gate, it will produce a 0 at its output. Notice that the B input also branches off and connects to the NOT gate. When a 0 signal is input to a NOT gate, it will invert the signal and produce a 1. The output of the OR and NOT gate are connected to the AND gate. The AND gate will receive a 0 and a 1 signal. This will cause the output at F to also produce a 0. So with this we can start to build a truth table for this circuit. A 0 on input A and a 0 on input B will produce a 0 at output F. Let's now change the A input to 1 and B input to 0. With a 1, 0 input going to the OR gate, it will activate and now produce a 1 at its output. The 0 output from B again travels through the NOT gate to produce a 1 signal. The AND gate now receives a 1, 1 signal and produces a 1 at F. We can now add this to the truth table. A 1 at input A and a 0 at input B will produce a 1 at output F. If we now change A to 0 and B to 1, the 0, 1 signal will turn the OR gate on and it will produce a 1. The NOT gate receives a 1 signal which inverts to produce a 0. The AND gate is now receiving a 1, 0 signal, which means it will produce a 0 signal at F. We can now update the truth table. A 0 on input A and a 1 on input B will produce a 0 at output F. Let's now place a 1 signal on both A and B. The OR gate receives a 1 signal at both its inputs, so it produces a 1 output. The NOT gate receives a 1 signal, so it is inverted to a 0. The AND gate receives a 1, 0 signal, so a 0 output will be produced at F. So we can now add the final entry to the truth table. A 1 on input A and a 1 on input B will produce a 0 at output F. Our truth table for this circuit is now complete, and we can see that a 1 signal will only be produced when we place a 1 on input A and a 0 on input B. Combining the logic gates together has allowed us to create a more complex circuit. Let's go to the simulator to view the working model. Here is the circuit we viewed before in the slides previous. It has two inputs, A and B. At the output there is an LED and a current limiting resistor. Let's test the circuit to see it matches our truth table. Input A and B are set to 0. When the simulation is started, the LED does not light up, so a 0 signal is being produced. Let's now change input A to 1. The LED lights up. Let's change A to 0 and B to 1. No output. And finally, let's set both A and B to 1. No output. This matches the truth table we created earlier. Let's move on to the next video to analyse another circuit.